It's a time you've been waiting for. Section 6.4. This is a good one. I'm going to split it. It's multiplication and division of radical expressions. Rather than jam it all in a long video, I'm going to deal with multiplication first and then a short video on division second. Also, if you get the multiplication and you don't need help with it, you don't have to bother watching it. I don't know how you could not want to watch it. But if you already get it, you can skip right to part 2, which is division. So my little hint here for multiplication, don't let the radicals throw you off. Know that square root of 5, that's a value. Again, you plug it in the calculator, you get an answer. Same with square root of 7. You can think of those, my little hint, Rhino hint, think of them as actual values. Thus, we can multiply together. You can think of them as an x and a y. You can multiply x times y and get xy. Then just wait for the values. And then if they give you a value of x and a value of y, you multiply those numbers together. That's what we're doing here. So the way you think of this, I believe the book breaks it down to show those two first, the numbers out front. You got 3 times 2, and then you multiply square root of 5 times square root of 7. So 3 times 2 is 6. Square root of 5 times square root of 7 is square root of 35. You always want to double check. You don't know what the book's going to give you. But square root of 35, I can't do anything with that one. So I'm going to leave it as is. So we're going to go to example 2, where they say multiply, and they give us a square root of 3 out front, and then a 2 times square root of 6 minus 5 times square root of 12. Well, what they want you to understand here is that you can simply use the distributive property. That times that piece times that piece. So using the distributive property, we have a square root of 3 times 2 square root of 6. And then we're subtracting, and I'm going to write it out front, but we have a positive times a negative, so you know it's a negative. Square root of 3 times 5 square root of 12. Well, when we get a case like this, we're multiplying the radicals together. Don't really worry about the 2. The 2 is just going to stay in place. Then we're multiplying a square root of 3 and a square root of 6. Same here. I'm going to say 5 times square root of 3 square root of 12. Square root of 3 times 2 square root of 6, we focus on the radicals. Multiply those, it would be like the x and the y. We'd have an x times 2y. So we'd have 2 times xy. I'm just replacing x with square root of 3, y with square root of 6. When we do, we already know that when we're multiplying, multiply those together. Square root of 3 times 6 is 18. Square root of 18 minus 5 times the square root of 36. So when we go up here, I'll rewrite it up here. Whoops. And I wrote it backward of what I've been doing, but 9 times 2. I have a perfect square here, which is 3. So I'm just skipping some steps now. I think you know by now. Square root of 9 is 3. 3 times 2 is 6. I'm left with square root of 2. Down here, I had minus 5 times the square root of 36. So in this case, the square root of 36 is 6. So I have negative 30. So what I actually have is 6 square root of 2 minus 30. We'll make sure the book, yeah, the book leaves it like that. You're going to see later on the book is going to move our radicals to the end. So we're done with that one. It's a matter of once you get to a certain point here, do what we did in section 6.4 and just look to pull a perfect square out. And don't worry if one of them has a square root of 2 and the other one doesn't. That might just be what the book did to throw you off, but you got to check. You want to see if you're going to be able to combine or if you just leave it. In this case, we're leaving it because one was a whole number, one was square root of 2. So again, that's like having this like having 6x minus 30. You would just leave it, 6x minus 30. You could distribute a 6 out, or factor a 6 out, but there's no point. It's not the of the section. Let's jump to example 5. And it says expand. Don't worry about the terminology, just look for what's set up and see what you can do. Expand just means, that's expand and simplify. They give us that. All that means is we have 3 times square root of x minus 2 times square root of y, and then we have it again, squared. So we multiply by itself. Doesn't matter what they give us. If they say squared, we write the whole thing again and multiply it together. Well, you know you're going to have a middle term that's a negative. You're going to have a negative something and a negative something, so you're going to have 2 of them. And you're going to have a positive first term, positive second term. Think of this no different than our rules. X minus y squared is going to be x squared minus 2xy plus y squared. I'm going to do it all out to make sure nobody misses out. I'm going to take my 3 times square root of x, and I'm multiplying it by itself. Then I'm going to take 3 square root of x and multiply it by a negative 2 square root of y. Or you could skip that and you could say you know you're going to have a negative. Then I'm taking a negative 2 square root of y here, negative 2 square root of y, and I'm multiplying by a positive 3 square root of x. And then I'm taking my negative 2 square root of y, and I'm going to multiply by a negative 2 square root of y. That's expanded. Now we simplify. I expanded it. Now I simplify. This is 3 times 3, which is 9. Square root of x times square root of x is x. That's what that piece becomes. Here, I have a positive and a negative, so I have minus. I have 3 times 2 is 6. I have square root of x, square root of y. I can't do anything with those, but I can combine them under the same radical symbol. Okay, then I have a negative times a positive, so a negative. 2 times 3 is 6. Square root of y, square root of x. So again, I'm going to write square root of xy. There is my 2xy. Remember, if I take x minus y and square it, I'm going to have x squared minus 2xy plus y squared. So coming up to my plus y squared, negative times a negative is a positive. I have a 2 times a 2 is a 4. Square root of y is y. If you see this, you should be able to get this without expanding because you know the rules. If you know the rules, use them. So I have a 9x. 2xy, in this case, I have negative 6 and a negative 6 is negative 12. So negative 12 square root of xy plus 4y. And that's what I'm going to write. That's expanded and then simplified. Okay. Let's do another one. We're going to skip just because of time. How much time do we? Oh, we're only 8 minutes. I just about could combine. I'll do them separately. Okay. So let's go ahead. We have plenty of time. We will do 2 more. We'll do example 6, which gives us something similar to example 5, only they're giving us a bigger quantity here under our radical, and then a whole number here. Still doesn't change the way we set it up. So what we have again is square root of x plus 2 minus 1 times square root of x plus 2 minus 1. You can use the rule x squared minus 2xy plus y squared, but I'm going to write the whole thing out so that we see it. I have x plus 2, and I'm going to multiply by square root of x plus 2. You already know that's just going to become x plus 2. And then I have, I'm just going to skip the positive negative. I'm just going to do it here. This is the way I like doing it. I like thinking I have a positive times a negative is going to give me a negative. And I have my x plus 2 times 1. Then I have a negative times a positive, so I have a negative, and it's 1 times x, well, I'll write the 1. 1 times x plus 2, square root of x plus 2. I'll put my parentheses around the second term that I'm multiplying. Then I have a negative times a negative is a positive. 1 times 1. Positive y squared is positive 1. Positive x squared is going to be square root of x plus 2 times square root of x plus 2 is just x plus 2. So I expanded, now I simplify. The square root times the square root, the radical symbol falls away. Here I have minus x plus 2 minus square root of x plus 2. I'm just combining those. That's the same term plus 1. So now I'm going to combine. I multiplied, I expanded, I multiplied. Now I'm going to combine like terms. I shouldn't have underlined that yet. I have 1x. There it is. I'm going to do, I'll do these first. I have my 2 plus 1. So I have 2 plus 1 is 3. Then I have my third different term is my radical. I have a negative and a negative, so I'm subtracting. I have an x plus 2 and an x plus 2, a square root's all the same. I have 2 of those. So I have 2 times square root of x plus 2. That's added, subtracted, none of them match up. I have an x, I have a square root of x plus 2, I have a whole number, so I'm done. That's how I leave my answer. Then we'll do example 7 and be done with multiplication, and then we'll switch it up. Okay, nice thing about video is I can erase them and move to the next one. Example 7. Last one we're doing for multiplication, then I'll do a really short video on division. It's not really that bad. Square root of 6. Oh, I see. This is setting us up for the division, actually. It is kind of making us, this is preparing us for division. In division, what we're going to do is multiply by the opposite. That's what we're doing here. We have the opposite. You can almost think the x squared minus x squared is x plus y times x minus y. So I'm going to take my square root of 6 and multiply by square root of 6. And then I'm going to take my positive minus negative square root of 6 times square root of 2. Then I'm going to take a positive times a positive, square root of 2 square root of 6. And then a positive times a negative is a negative, square root of 2 square root of 2. Again, remember the rules. Perfect square minus a perfect square is plus minus. We have the plus, we have the minus. You know you're going to end up with a perfect square minus a perfect square. What we have is a perfect square. 6, square root of 6 times square root of 6 is 6. We have plus minus the middle term. They go away. Negative square root of 12 plus positive square root of 12. They're gone. And then we subtract my perfect square root of 2 times square root of 2, minus y squared. So square root of 2 square root of 2 is 2. And here we get a value of 4. And we're at the 13-minute mark, so I'm just going to cut it off here, and I'll come back for part 2, where I'll discuss division, which this sets us up for. This is jumping us into division. So keep this thought in mind for the next video. See you in a bit.